Can y'all hear me? Alright, we are live, guys. I'll put this on Rumble. Can y'all hear me, guys? We got 2 people in the show. Let's go. It says 2 people, me, myself, and I. Alright, guys. And, yeah, see who's in the chat. Can y'all hear me? How's my audio? I'm gonna check out if Rumble's working fine. Alright, so today's gonna be a interesting stream. And I. Alright. Alright, so lots to talk about. Okay, we get a rotary motion in the house. Let's go. Yeah, I'll fix this up. Yeah, maybe, let's see. Okay, so that's, okay, rotary motions in the house. So I'll make this bigger this way, and I'll slide this over. Okay, this should be good. Alright, that's good. Yeah, I'll maybe make it a bit smaller, maybe. Okay, how to make this a bit smaller. 1 down. Yeah, I should be fine there. Okay. Alright, we are good to go then. Alright, guys. So we have 2 people in the show. Let's go. And yeah, today's gonna be quite interesting. Okay, Nico Becker's in there. Okay, so on Rumble's working. Nico Becker, nice. Okay, let's go. And do you guys see that? Did you see the trailer? I put in. It was made by Attila. It's pretty epic trailer, and there's no copyright on the music, so that's pretty good. All right, so I'll play that right now quickly. Well, you can also go to the trailers playlist. All right, yeah, so we can go right here, and you can go to the trailers playlist, or you can just scroll up here. So he made these epic intros. I think he used Canva. Let's play this one here. Oops.
Okay, it says I'm live.
Okay, there it is.
6 people. Alright, we are in. I was just talking for 5 minutes.
I think he got it from my first stream. I was like literally, I didn't realize I was not live, and I was talking for 5 minutes.
I was just someone says okay, live. Apparently, I wasn't live.
Let's see how the beginning is.
Going live. Okay, it says I'm live. Alright, we are in. I was just talking for 5 minutes, and I thought I was live. Apparently, I wasn't live.
Alright.
Okay, I'm going.
Alright, anyways, guys. So yeah, today's live stream is gonna be quite epic. It's gonna be a lot of basically gonna discuss gravity and basically just go over the questions people had for me and so on, but also go over what the mainstream narrative on gravity is, and then go from there, and also tell you what's going on right now. And also, here's the Leo threads. If we get people on Hive, all your comments will be there forever, and this will be updated. Then you get upvoted, you're in crypto as well, so you don't need to worry about YouTube censoring or anything. So again, if we get if we get enough people on that, I'll use this as the main one as opposed to the YouTube one. All right, guys. Anyways, the next thing is I want to. There's some big news. Sad news, guys. Let me just go to my. Yeah, so basically, John Hutchison, he's in the hospital again. So sorry, but yeah. So basically, prayers up for John. So Nancy just emailed me when I was sleeping. So 9 a.m. This is 1 a.m. She said same as last June, had to give John CPR. Yeah, John had another episode, basically another heart attack. So last month after the stream he did with me, he woke up like he was unconscious. He had a big heart attack, and then he'd take a hospital. And I think they have some sort of heart monitor on him now. But anyways, and then now Nancy, his wife, just messaged me saying that she had to give him CPR again at night. He's in hospital here in Willits, and they're transferring him to another hospital, Santa Rosa. Charles, he's the one that actually he let me borrow his phone to the hotspot for the live stream tour of John's lab. So yeah, it's staying at the hospital with John, and we'll drive to Santa Rosa, 1.5 hours away, while they take John in an ambulance. They don't know when, so I am home to get a few hours of sleep. Unbelievable, guys. All right, guys. St. David's, bless up Matt in chat, and also bless up John Hutchison. Hopefully he is good to go. Guys, he's also supposed to be doing a stream on April 5th. So April 5th stream. It was him. Yeah, John Hutchison was supposed to join on April 5th, plus Paul Wheeler from the Paul Mueller from the Inventor 3 channel. So that's going to be quite fascinating if John's able to make it. But anyways, so that's quite sad to hear. But anyways, so again, last year, same thing happened. But luckily he came back to life. All right, and then another part is I want to quickly state that, so this Saturday, if you haven't seen, so I haven't seen my streams. So this Saturday, we actually have a special guest, Dr. Daniel Nagas. So if you haven't heard about him, so the guy who runs this pretty big Substack. So Alan Force kept telling me to get him on here. So then I emailed him. He says, yeah, he'd be able to join. So this is Dr. Daniel Nagas. Yeah, Gary Jackson. Sorry to hear about John Hutchison. Get well soon, John. Yeah, prayers up for John. All right, we have St. David's. God bless John. We'll keep him in my thoughts and prayers. Yeah, for sure. That's prayers up, guys. Get John up and running again. It'll be quite fascinating to see. Hopefully he's back, but also, but again, guys, John is still, he's 79 years old, turning 80 this year, I think. So, and now it's gonna be like a second heart attack in like in a year span. And also, he had knee surgery. He had like a big giant knee quote infection, where they had to, yeah, it was like a big giant thingy on his knee that the surgery off. So, anyways, so basically, what I'm trying to say is, we're gonna have to take the void of John Hutchison and the Hutchison effect and so on. That's I'll just take the lead for now. Anyways, and Bob Greener, hopefully he gets on the same page and gets away from Master Force. All right, guys. Anyways, but also this guy here is gonna be on Saturday. So this guy, Dr. Daniel Nagas. The only critique I have is that he believes in the germ theory. But anyways, he's a big anti-COVID doctor, for a local one too, and that he was fighting against the government for their tyrannical mandate and so on. And also what was fascinating is, for those who live in near like Vancouver, BC, there was actually an emergency alert, an BC Amber Alert. I got this last week. This is a BC Amber Alert of British Columbia alert issued by Vancouver Police Department. The abducted male child is Theodore Lim, described as 2 years old, 2 feet tall, 35 pounds, short brown hair, wearing all gray clothing, black shoes with white soles, on ventilator, last known this part, East Broadway in Vancouver, BC, at 10:39. March 13, 2025. The suspect is Davis Lim, the father, 5 foot 9 inches, and so on. And possibly traveling in blue 2006 Volkswagen. So initially I thought it was like some sort of like parental issue or like divorce issue and so on. And then I got the link sent because I from Daniel Nagas, because I said, hey, to confirm if you're going to be interviewed on this Saturday, the 22nd. He's like, yeah, for sure, but he also said he's really busy, and he sends me a link to this one here. So Theodore's medical status. So that Amber Alert, the father actually brought that kid to him because he's an emergency doctor. And Theo, and apparently, and then he said that the SWAT team came in and like literally took the kid and like also like I think they either hit or traumatized basically everybody there, and they got him in like handcuffs and so on. But apparently, the family wanted the kid out of the hospital, but they're like forcing him to be on ventilators and all that. So it's quite like ridiculous. Yeah. So it's gonna be good to see what happens there. Oh my goodness. Yeah. Let's see. And then Bob John, wow, that's terrible. Yeah. And then Tammy, oh my goodness, he was making such good progress for praying for John quite a while, and for Green Year to get on the right path. Forbes is a 4-0 shell. Yeah, he is. Coming in late as usual. Yeah, Timothy Sullivan. Yeah, if you haven't heard of the news, John Hutchison is in hospital again. For those just joining it, he heart attack second time in a year span, and so he's in a hospital. And hopefully he's good to go. And so St. David John's work on earth isn't finished yet. We still need him here. Matt, get all the knowledge and wisdom you can from him while we have him. Yeah, for sure. I pretty much have absorbed a lot of info, so that's going to be fascinating. Yeah, but anyways, for me, it's just more about focusing on this and also getting my life in order. Mainly the crypto taxes issue. Once I get that sorted, and then I'm good to go. And but anyways, fund the operation, guys. The more money you send to MES, the more time I have to focus on this, because we're gonna need this big time, and so on. Anyways, just so I can focus on this full time as opposed to doing other random stuff I do. Yeah. So anyways, guys. So and also. Yeah, so this is the Saturday stream. Yeah, so this morning I was the John Hutchison news kind of threw me off. It was sad to hear. But anyways, we will continue further. Also, yeah, so we have that stream, and then let's see, April 5th. Yeah, I pretty much have guest streams every other week for like over a month, and that's gonna be. And then John Hutchison, hopefully he's back on April 5th. So April 5th is supposed to be John Hutchison and Paul Mueller. So, but anyways, let's power through, guys. So again, for those get on the on threads on Inleo. You earn crypto. All your comments there forever, never get deleted, and so on. Anyways, guys, let's power through. Okay, we're getting people in the show, and so on. Okay, I'm gonna go to the next setup here. Okay, so I'm gonna open up my links to stuff I had here, and the reason I called this this stream "What is Gravity." I had a critique there. Okay, Timmy Sullivan, let's go. Sending a bunch of cash money. This is 20th super on the live stream. Yeah. Thanks for donations, guys. Again, donations help a long way. Mainly just so my goal is to do this. Like focus on this, and then like anything else I do on the side that earns money, I just do it more passively, as opposed to focus on it. I had, had a talk with the CRA, the Canadian Revenue Agency, because they were doing an audit on my crypto taxes. So I had to talk to them for 3.5 hours. My goodness, half the talk was just me teaching them what crypto is. It's like the person auditing me has no clue about what crypto is, and I'm trying to. Anyways, and taxation is theft, guys. Anyways, and also speaking about crypto taxes. So I initially bought this one, but then I realized I just got a refund because I don't want to. They said once crypto CRA does my taxes, they do an audit, and then I'll use this to compare how accurate it is, and then see if it's worth it. But anyways, I was using I initially paid for this crypto tax calculator, and then the website, they literally got this freaking Illuminati calculator with the they're doing a Jay-Z the pyramid there. And they got the inverted all-seeing eye, pyramid with all-seeing eye inside, and it looks like a watch/eye. So it's like, what in the world? Out of all the imagery that they have, is this stuff? Is a crypto tax calculator. So it's like, and that's like some Aleister Crowley type symbology too, that hand sign. So like, what in the world is going on here? And you can see this is the stuff they have, is that little thingy. But when you sign in, they give you that freaking Illuminati nonsense. All right, anyways, guys, let's go continue on further. Pizza slices on top wedges. Yeah, so anyways, guys, thanks for donation again. Tim, it goes a long way. And yeah, I noticed that JFK files, I saw your comments there. So they're releasing JFK files. Apparently they released 9/11 files too. So I think we're going to have to invade Qatar. So that's going to be the only downside of the JFK and 9/11 files. They're going to say JFK was actually assassinated by Qatar, and the alleged hijackers were from Qatar. So we're going to have to invade Qatar for oil. All right, guys. Anyways, continue further in our journey. So anyways, going back here, I'm going to keep this on this. Actually, I'll keep this here until I get one comment on there. So whoever gets the first person to get on Hive and post on there, it'll be quite epic. And I'll be meeting with 9/11 revisionist, trying to give him a tutorial on how to get on Hive, because he'll be a big proponent, because he make a lot of cash on it. Anyways, I'm gonna go through some of the here's the links. I'm gonna go through one by one. But the main one, first one I'm gonna go over is, I got a comment from someone. See, these are some of these were from last week's. I just want to go over to, okay, this one might have been one of these comments. Someone gave me a critique because you're saying, oh, gravity has nothing to do with magnetism and so on. So I'm going to read theirs, and that's why I'm going to call it, I called this thing, what is gravity? I'm going to see some of the comments here in my last stream. So in my last stream, I got a whole bunch of comments. Okay, this guy here seems to be a normie. Just, oh man, come on. Gravity is the curvature of space, okay? Has nothing to do with magnets. This is ridiculous. We already understand all this stuff, okay? All matter is comprised of fundamental particles, and all fundamental particles exist as mass confined to 2 dimensions. It's like, okay, so he's explaining gravity. by saying it's a curvature of another thing, space. Another question is, what is space? All right, and it's nothing to do with magnets. All right, so now he's saying gravity is curvature of space. Okay, so the question is, what is space? So so his explanation for gravity requires a more complex, undefined thingy here. So it's a curvature of space. Okay, so again, talk to me like I'm like 3. Okay, all matter is comprised of fundamental particles. Okay, and so matter and particles. So again, another a bunch of undefined stuff here. And all fundamental particles exist as mass confined to two dimensions. All right. So now we got it's like talking to some witchcraft here. A particle's positively curved in the case of an atomic orbital. Okay, so it's a positive curvature in case of an atomic orbital, flat in the case of a free electron. So a particle is positively curved and negatively curved. Okay, now you're adding a plus and minus. So basically every single sentence is filled with unknowns, and then he's acting as if that's common, like it's obvious. Anyways, negatively curved in the case of an electron as a pseudosphere. Sorry guys, I'm just reading mainstream quantum mechanics, or this guy's interpretation of it. A pseudosphere here called the pseudo-electron, the effect of this curvature of the non-local space-time. Now he just added another space-time in here. Where is the space-time coming from? It's the curvature of space or space-time. It's to cause it to be Riemannian in the case of an atomic orbital. Or hyperbolic in the case of pseudo-electron, as opposed to Euclidean in the case of the free electron. Each curvature is manifest as a gravitational field, a repulsive gravitational field, or the absence of a gravitational field, respectively. Thus, the spacetime is curved with constant spherical curvature in the case of... Okay, anyways, I'm like having a brain aneurysm. Did Jimmy Reese type that? Okay, or Ashton Forbes, one of them. Thus, the spacetime is curved with constant spherical curvature in the case of atomic orbital, or spacetime curved with negative curvature in the case of pseudo-electron anti-gravity. All right. So now we will ask. I'm gonna ask Grok to decipher this. Okay. What does this person mean? Is it a joke? Okay, let's see. Okay, let's see here. It's a joke? Okay, it can be one of two things. Okay. Okay, so the person's comment starts with a seemingly exasperated tone, dismissing a connection between gravity and magnets, and asserting that we already understand all this stuff. This suggests that they might be reacting to someone else's misunderstanding or oversimplification of gravity, perhaps in a discussion or debate. The first part, oh man, come on. Anyways, gravity's curvature of space has nothing to do with magnets. This is ridiculous. Reads like a frustrated correction, possibly meant seriously, but with a hint of sarcasm or disbelief. They're mocking it. Then they launch into a highly detailed technical explanation about fundamental particles, their curvature in spacetime, and how this relates to gravity. Terms like pseudo-electron, Riemannian spacetime, hyperbolic curvature, and antigravity are thrown around in a way that mixes real physics, concept spacetime curvature from general relativity with what seems like speculative or invented jargon. Pseudo-electron isn't a standard term in physics. The explanation is dense and convoluted, which could mean one of two things. It's a joke. The shift from casual, or it's serious or serious-ish. They might genuinely believe this is a valid explanation. Anyways, so Grok's not even sure, and it says right here, my gut's saying it's slightly a mix of both a semi-serious attempt to explain something wrapped in exaggerated complexity that could double as a joke. Anyways, I have absolutely no idea what that person is saying, and if you do, please do something about it. Anyways, but anyways, saying it's nothing to do with, let's assume that he's at least saying that it's nothing to do with magnetism. Let's say he at least believes that part. But the thing is, John Hutchison shows that magnetism affects gravity. So then whatever the theory of the mainstream is, it's if it doesn't include it, it's wrong. So basically, if it doesn't match, as the Richard Feynman, again, I think he's some sort of a deep insider. Feynman, I think. Feynman, if it disagrees with experiments, it's wrong. Let's play this one in here. Let's do it short.
Now I'm going to discuss how we would look. Then we or if it disagrees with experiment, it's wrong.
Yeah, so basically,
Experiment. If it disagrees with experiment, it's wrong.
yeah. So anyways, if it disagrees with experiment, it's wrong, okay? So if magnetism and gravity are related, then any theory that says they're not is wrong, okay? So it's, again, it's very, very simple stuff here. Okay, so that's that part. And I'm going to go over one by one here. I think there's another comment here. There's a lot of comments earlier and so on. Okay, this one's a comment here. What's a comment over here? Okay, oh, this was Attila. He's the one who actually made the trailer. This is math. I have a theory about magnetic field and gyroscope, but I'm not so unacademic that I can't even begin to explain it. I might do it like John Hutchison cryptic, but I doubt do it. Do some experiments to see if your theory works. Basically, that's the thing. Experiments over anything and everything. Yeah, Tammy says, sounds like a bot has joined our party. Yeah, that was quite, that comment was quite fascinating. All right, guys, next part, I'm going to go over, so basically I have a bunch of links here, and then go over it one by one. Feminist Deep Insider, along with Sagan and Sagan's wife, she appears in Gage's videos. No way! Gage associated videos. Gage associated, Sagan's wife, no way. Okay, yeah, obviously the big insider agents. And the reason I say the big insider is because it's like, advanced tech exists, so anyone that's propped up as being like an advanced scientist, guys, and they don't talk about advanced tech, advanced science, like then something's up. like why aren't you talking about it? And like why you're obviously going to be aware of it. You're obviously are exposed to all this info. People obviously tell you, hey, you know this Hudson effect is actually levitating stuff. Anyways. So it appears in Gage associated. Yeah, if you could send some links on those, that's gonna be quite fascinating. All right, guys. Anyways, I'm gonna go over one by one of these links that I put in here, and I'll try to use this Wednesday stream as also answering random questions, just so my Saturday streams to be more focused on the topic. Anyways, so speaking of gravity, this one is obviously a must. If you haven't seen this, I saw this this video actually uploaded to my Telegram. I think it's very interesting, and again, I think it's very telling. So it's a very interesting 2012 presentation on the likelihood of reduced gravity being the reason for dinosaurs' great size. So if you haven't seen this, and this one, when I came across this info from Lloyd Pye, actually, when I was watching some Andrew Johnson videos, at first, Andrew Johnson and Richard Hall, they talk about Lloyd Pye. And then, assuming gravity, assuming dinosaurs are real, assuming that's not some sort of other psyop, the great size, it's almost certainly just because the gravity was less. In other words, the Earth was smaller and it's gradually building up mass. Okay, Timothy Sullivan, we need a telephone conversation regarding my vague impressions of the frauds at the top, including Roger Penrose. Yeah, for sure. But also, if you want to join a stream one day, and go over, we can call it Spooks at NYC or something, or Spooks around NYC, and basically go over all your info. Because you pretty much know every names of people. I am not a names person. I just drop info basically. If people don't talk about 9/11, then I have put them in a category, and then from there it's like, and if they don't talk about advanced tech, Hutchison effect, if they're a scientist, then I put them in another category. It's like you gotta get through past the category before I can like take you seriously. I read Earth was smaller and less gravity, hence dinosaurs. Interesting. Yeah, gravity is less. But the thing is, what's very, very telling is like. There's a couple things. If you see an elephant, right, the bigger the animal, the slower it goes right now. Like an elephant is absolutely slow motion. But then the other dinosaurs, they're like massive, but like for example, T-Rex is massive, yet somehow it's moving around like it's nothing. So in other words, it's either their bones are somehow magically infinitely stronger and bones and muscles, but that's contrary to like the current largest animals. So it's like, and also the size effects. When something gets bigger by like, let's say if you double the width, the actual volume gets much bigger, and also the amount of force on their bones is much bigger as well. So basically illustrated right here. This was a good one here. So if you take a little size right here, if you have length 1, 1, everything's 1. If you just normalize everything as volume area 1, so and if you double the length right here, so length 1, so if you have, let's say, this leg right here doubles 1. The area doesn't double. The area is 4 times more. So yeah, that's the thing. Yeah, so if you take a, let's say if you double from here to here, if you double these, you can think of it this way here. So the area, right now there's 1, 2, 3, 4, 5, and then 6. There's 6 sides, or 6 faces. So that the area would be 6. But then if you double the size right here, you're gonna have now. There's gonna be 1, 2, 3, 4. 4 times it by another 6, so 24. So this had 6 sides. So area 6. This one has 24. So the difference is 4 times. So 6 times 4 is 24. So the area actually does a 4x. The volume, if you count all these cubes, so this one, the volume is 1. Now there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 cubes. So in other words, the volume's double. And now what you have is the mass is, yeah, and also the mass would be 8 times, is mass related to volume. So this is mass 1, just 8 of them. And then the other part is gravity. Yeah, so gravity is, yeah, gravity is just 1. And then, but then now the force on, for example, on the joints right here, that's going to be mass, yeah, that's going to be force is equal to mass times acceleration. But the mass is 8 times bigger. So this cube, if you have the exact same right here, and then you double the size, you just double the length right here, the mass is 8 times more, but the area is only 4 times more. So area is the number of faces on the side. So in other words, the mass, yeah, so the force is going to be 8 times more. The area is going to be 4 times more, not 8. So in other words, the stress on the legs is going to be force divided by area. So 8 divided by 2. I mean 8 divided by 4 is 2. So the force. So when you have a little animal right here, and then if you double the width, if you just double the width of the size, or the width of or double the length of it, it's gonna be 8 times bigger volume, 8 times bigger mass, but the force on the joints are double. I mean the stress on the joints are double, so they don't just scale up regularly. So the smaller the animal, the less stress. The higher, there's actually double the strength. So the bones need to be double the strength of a normal animal. Yes, the bones and muscles need to be double the strength. Tell me everything vibrates in some sort of direction, and the matter keeps similar patterns close. Others are either repulsed towards various angles. This can cause disturbance in the material. Okay, not sure. Okay, I heard it was. Anyways, yeah. So yeah, going back first. First, I want to make a schedule here. So Timothy Sullivan, if you want to join the live stream, because I think you'll be a great guest. You have infinite info, and a lot of people already know you. I have a bunch of streams already lined up. What I would do is I want to alternate solo and guest ones. So this Saturday is going to be Dr. Daniel Nagas. And then April 5th is supposed to be Paul Mueller and John Hodgson. And then April 19th is Methyl Minor. And then May 3rd, I have a random guy on Telegram who's apparently a biodigital convergence expert. And then so May 17th. So Timothy, May 17th live stream is yours. Okay, we'll do spooks around NYC or something, etc. Okay, let me know if you're interested. May 17th would be a perfect time. It will fit in my schedule. Basically, I alternate solo and then guest, solo, guest, just so I can power through, do my usual stuff. Anyways, so going back to this dinosaur stuff. So if it's double the size, I mean double the length, the mass is gonna be 4 times more. I mean 8 times more, and the stress on each of the joints would be double the stress. Okay, going back further.
Has increased 2,000 scale effect, still available.
And here's an illustration of this. So here's the exact same proportions. This was from a BBC documentary, BBC lecture. This part right here. So this is an animal.
Animals around. It demonstrates the same scale effect on life we have just looked at. The small animal can stand on its legs, but what will happen to the larger animal? The legs collapse because of the scale effect. This series of Royal Institute lectures on scale effects are well worth watching and are still available on their website.
Yeah, so this one here, why elephants can't dance. So basically, what they're literally saying is why dinosaurs don't exist. I mean, dinosaurs' size is impossible unless there was a small gravity, or there's some sort of weird psi they did. And then this one, I think this was a comparison of the bones, and also the bones of the, this is the elephant, this one's a rhino, this one's a deer, and this is the relative size of them. But the thickness, they need to be thicker too each time. Each time you need to be thicker. So the question is, do dinosaurs have some sort of advanced like metallic bones, or they don't? And again, so basically there's a limit to the size, and then you can calculate from the size, and you can and not just like Tyrannosaurus Rex and all these regular dinosaurs, but also like everything was just bigger. You have a dragonfly right here. Again, assuming it's real. I always say that because when you deal with the conspiracy world, anything is possible. So this one right here is like way bigger. So the question is, why is this way bigger? Why is this a little wing? Is it also being like some sort of metallic, super strong fiber? But if it's the same stuff that we're used to, then it's pretty much in my book. It's like very hard to argue against less gravity back then. Okay, and then and also you can see even those giant ones where their necks were super long. In order to have the necks and also to be able to have the muscles to pull those back, to be so the muscles itself, it's like, what are these muscles being made of? Are they made of some sort of alien fiber, or just regular muscles but less gravity? So the only way is less gravity would fit in. So if the gravity was half or so on, and these are also similar size animals. Everything was just bigger. This was like a triceratops, similar to a rhino, but much bigger, and it could also gallop and move around. So the question is. And it's like an elephant size, but it's dynamically apparently supposed to gallop as well. So it's not that easy. Okay. Anyways, and then going further, this gravity variation is based from scale prehistoric size, and then basically, if you try to scale everything down so that they're the same size, or the same stress on their bones, the gravity would have to be, let's say, in the dinosaur period about 0.5. Yeah, about 0.5 right here, up to 0.4, and then if you have the giant insects. So the giant insects one, I think that's the biggest giveaway, that obviously gravity is less. Like, there's just no way around it. Okay. And what's interesting here's surface gravity, the moon. This is a comparison of it. And also, this guy made this 3D model. If you turn all the continents into a ball, it fits in neatly.
Ancient reduced gravity Earth is remarkably similar to the geological evidence for an expanding Earth. The geological evidence indicates that the present-day continents were once joined to form one large continent, but as the Earth increased in size, the continents began to split as new ocean floor filled the gap. These are my own reconstructions I produced in the early 1990s, but they are remarkably similar to other reconstructions we have seen at this conference.
Yeah, but anyways, this was like apparently expanding Earth conference. I think the flat Earth stuff was it's used to basically counter this information. This information shows gravity has been changing and gravity control. What I found the biggest censored topic or a convoluted topic is gravity. Gravity is the big one because it gets you off the ground, and it's also, I think, gravity, anti-gravity stuff like that, is like a physical manifestation of like actually being free from tyranny, like world tyranny, where it's like they literally keep you grounded. And if once you fly above and you're like, hey, wait, it's like, what's all these roads and cars for? And like, what's all this government for? And again, I think government mainly is just to keep gravity control suppressed. That's pretty much it. That's my 100% takeaway from this, and hence the Freemasonic G. So this one here, Freemasonic G logo. Let's see here. So I'm making some stuff on the fly right here. So this one right here, this is a secret of, this is the holy, like they have this, the Freemasons call the apron like the Holy of Holies, where they're covering their like D or whatever. But I think the letter G stands for gravity. My personal like subconscious or my personal view is that the big G is just this whole thing is to cover up gravity control. Gravity is the absolute big one. What factors are needed or working on gravity to change it? Atmospheric size getting smaller. No, it was smaller before. So the one one explanation is that from the internal, from the internal process of the Earth, it's actually absorbing energy either from radiation from the universe or from some sort of cold fusion from the center, or both. So let's say you have radiation coming from anywhere, possibly some cold fusion some cold or hot fusion or whatever. But I think cold fusion process in the Earth that's growing it, making it bigger and bigger and bigger. So something I think there's a good chance of that, something like that happening, where it's growing slowly, so it's actually building more mass, and so on. So I think that's something happening there. That's one good take on it. But again, letter G, MES duality. It's to cover up gravity. Because again, if you can literally fly, like you're gonna have a little device that can fly. Like what are we doing here? So again, that's my take it or leave it. But anyways, I want to go through another thing. There's a couple of sites that are pretty good on this. I'm gonna go to so Fractal Woman's good. Fractal Woman, she has some good thoughts on gravity. There's a couple of ones that actually have okay, so gravity. Okay, why does gravity only? So if you have some good sites here, these ones are explaining gravity pretty well. And I think she asked this person what gravity was. But anyways, so gravity right here, again, it's related to fractals / magnetism. And then there's another one, I think it's called It's BS. Yeah, so this channel's pretty good for the most part. For the most part, he's pretty good. Gravity, basically he shows that the Einstein relativity stuff is a bit out there. And he's also banned from like physics forums on Reddit. It's pretty interesting. And he's the anti-quantum mechanics, and so on, and basically, the whole quantum entanglement, and so on. I do think there's something to it, where I just want to see the single photon definition, and it basically, and again, it all stems from this part. The photon is wrong is based on a second of time, and if you do, I just want to put these references if you want to look at these stuff. I think there's something to it, and also there's another guy. What's his name? This one I did contact him. What is his name? Ether or something. Ether. Oh, so this one is another good one. This one I was. Okay, Dino, I've asked him to join the stream, so that'll be one day. But he's still busy. It doesn't want it. But he's written some papers on gravity there. But there's another one I just want to get to it quickly, just for my own reference. Do you know anything gravitational lensing and what that is or does? I think that's just magnetism. So on gravitational lensing, you can go right here. Gravitational lensing. It's similar to. I think this was years ago.
So today we're going to talk about gravitational lensing.
Yeah,
what I'm going to show you in this video is the self-similarity between that I have between magnetism and black holes. Einstein, this bluish tinge being lensed in a similar manner to the way this magnet is lensing the white light. These magnets would just disperse. Okay, so what I'm proposing.
Yeah, basically, gravitational lensing is similar to what would happen if you put a magnet in a ferrofluid, and then shine light on it. So basically, the light is interacting with the little particles. But in this case, gravitational lensing would be, let's say there's an ether that lines up with I think this is like a cloak around a force. I'm trying to say gravitational lensing. It's just magnets. Literally light. If you put a magnet in a ferrocell, you get literally very similar effects as this stuff. Here's an actual black hole on the left, and this is a magnet like that. Like you shine light, depending on where the light's coming from, it will look like that. And here's a black hole. So black hole. This is a black hole image that they generated from a bunch of data. But if you put a magnet in the ferrocell, it's literally the same thing as a blob. So basically, the thing is, space would be like filled with like this ferrofluid, just little tiny nanoparticles. In this case, it would be ether. So the light is interacting with the ether. Yeah, the Grok symbol. That's interesting. Yeah, that's where you got it from. So Grok is like Saturn / that's it. But anyways, I do need to dive into that a bit more. but I've been focusing more on the experimental side until I get a grasp of the Hutchison effect, and then eventually the theory, stuff like that. So anyway, there's this. I know Dean knew there's another one. Ethereal mechanics. Okay, this is another one. I just wanted to get it from my reference. Ethereal mechanics. He has a good one on gravity, electrogravity introduction. So this was 2 years ago, electrogravity introduction. He does a lot on this stuff here, and he's also trying to make a model on it. Gravity is a force after all. So gravity is a force. What does this guy talk about? Gravity is a force.
Hi folks, welcome to electrogravity video series.
Actually, no, he had some good stuff on gravity. Anyways, basically, my view is that gravity, okay, electrogravity, matter, and ether. Where's the, when he started? Okay, this was a good one on gravity.
Hi folks, welcome to Ethereal Mechanics Electrogravity. This is the second video in the electrogravity video series, and today we're going to be talking about foundational topics. And of those topics are ether and matter. And so the topics today are going to be ether. We're going to talk about the large scale and the small scale ether model. We're going to talk about matter and why matter must feed to exist. And then we're going to talk about the relationship between matter and ether. So let's talk about ether. Now let's go back to the beginning with Einstein's principle of equivalence. Einstein postulated that if you have a man in a spaceship here, and his engines are accelerating him through space at 9.8 meters per second squared, he's going to be forced against the bottom of the spaceship with a force equivalent to 1g. In other words, that's the force equivalent to the gravitational force of the Earth, 1g. Now, if you take this spaceship and you land it on the surface of the Earth and shut off the engines, well, sitting in Earth's gravitational field, the spacefarer is also going to feel the effect of 1g. Okay, but here's the Achilles heel of relativity. Relativity cannot explain inertia. Okay, they use that fabric of space-time, and this model works very well for gravity, but it does not explain inertia. And so that is the sucking chest wound of the theory of relativity, is that their model can explain gravity, but it cannot explain inertia, no matter how much Einstein says they're equivalent.
Okay, yeah. So this is that curvature of space mumbo jumbo, where you can, if you just have like a little bent there, somehow gravity goes in it like that. But again, he's talking about inertia. So each thing has it requires some sort of force to move anything. So everything's got some sort of mass, inertia, basically resistance to change. And rotating motion, interesting. Elon used that exact word, ethereal, in a recent interview. Interesting. Yeah, ether is, I think, is a big one. Once you discuss in that terminology, instead of this quantum particles and all this space-time going entanglement, quantum entanglement back and forth, mumbo jumbos, going forward and backward in time. It's like, anyways, just give me the antigravity, and then I'll listen to any theory you have.
And that is the ultimate fail of the theory of relativity. Now let's go and look at
mass times momentum equals velocity. No, it's the other way around. Mass times velocity equals momentum. Momentum is basically, momentum is the just how much mass is being moved. Yeah, so momentum mass times velocity. So the faster you are and the higher mass. So momentum is calculated as product of mass and velocity. Yeah. Friction, vibration, ether creates heating, cooling, pushing, pull, gravity, dispara, and electromagnetic effects, etc. Yeah. Basically, I think magnetism is just ether rotation. Electricity, I think, is ether vibration, and that's it. and yeah, we'll get actually another part I want to go over is magnetron in your microwave oven. That's pretty much a spinning electron that vibrates ether. Anyway, we'll get to that in a bit. I just want to continue with this part here because it's really a demonstration.
Ethereal mechanics. Using the same thought experiment. Okay, this is a demonstration of the ethereal mechanics analog. This green mat here represents empty space. And what I'm going to do is I'm going to introduce the medium. This piece of graph paper represents the medium, the ether. This frame represents the spaceship. And this little nut represents the astronaut. Now, in this analog, velocity relative to the medium is the analog of acceleration relative to the ether. Let me say that again. Velocity relative to the paper represents acceleration relative to the ether. That is what this analog means. Now, as you can see here, as if I have the astronaut in his spaceship.
Yes, yeah, so he already said it. In this case here, the force that this thing feels, that's equivalent to gravity, is just motion relative to the ether. So I think that's a good explanation for gravity.
Yep. And they're just sitting in free space. The astronaut can bounce around weightlessly. But once the spaceship is under uniform acceleration, he's going to be held against the back of the spaceship. That is inertia. Now, let me introduce the analog for gravity.
Then here, just fast forward to that. Okay. So gravity is the other way around, as opposed to...
If you're going to do this demonstration, I put...
gravity's the other way around. Instead of you moving relative to the ether, ether's moving relative to you. So ether being friction? No, ether is basically what like a medium where everything exists. So again, the question is how does this relate to the actual ether in terms of what they are? That'd be an interesting discussion. But anyways, go one step at a time, guys. Dia typo above, which went with other previous posts. Interesting. All right. Para dia.
Little spacers underneath here made of a 3x5 index card folded 4 ways. That gives enough space so the paper can slide underneath pretty easily. So this bar here represents the surface of the Earth. Theorem of mechanics gravity is that the Earth.
But anyways, that's actually a good analogy. You had ether being friction, or ether having friction. So the ether or that friction. I think that's another analog for inertia or momentum, because so the inertia of a mass, it's like stuck to the ether. When it drags relative to the ether, it requires a force. So that, in other words, it has inertia because it's like pretty much clinging to the ether. And I think this will explain that as well. Because watch what happens. Because that ether is stuck to this one, and then when you move the paper down, the ether, it's dragging, so that inertia is pretty much dragging everything down with it. But then if you have the Earth, for example, being rigid, it's going to be pushing on the Earth. But anyways,
Earth
we'll go over
consumes here. The mechanics of gravity is that the...
So yeah, so basically his theory is that the Earth is eating the gravity. So in other words, all objects are eating, eating ether. So they're consuming the ether. That's the only way to exist, is to consume ether. So we're getting pulled by the Earth. The Earth is pulling the ether, and we're getting dragged along with it, and hence gravity.
Bar here represents the surface of the Earth. Theorem of mechanics gravity is that the Earth consumes the ether, and therefore it will pull a falling spaceship without its thruster on, and the astronaut inside the spaceship, as they're in free fall, falling toward the Earth, that they're not going to feel any gravity because they're moving with the ether. They're accelerating with the ether. The minute the spaceship hits the ground, then the astronaut will keep on going until gravity holds the astronaut against the bottom of the spaceship. And that's how you explain gravity with the ethereal-mechanics analog. Let me put more gravity out here.
And this might explain Earth getting bigger. So if it's always consuming ether, so then it's getting a bigger and bigger, more mass, and hence gravity less for dinosaurs back then.
And it's interesting because if the astronaut decides to jump, well, gravity will keep having him come back. And there you have it. It's so easy. Even a 5-year-old can explain it to a physicist. And therefore, with the medium, we can explain both as the same effect. Not equivalent, the same effect. So ethereal mechanics owns the principle of equivalence because it's not equivalent, it's the same. And you got ethereal mechanics for the win. Okay, but an interesting thing arises from this Earth pulling in the ether. We come to one of the most quintessential quotes of ethereal mechanics. Gravity sucks. Okay, so what happens is the Earth is consuming the ether. And because ether is a fluid, it's going to flow from high concentrations to low concentrations, and it's going to flow toward massive bodies. Okay, and so what actually holds our guy against the floor is actually two forces. Okay, two forces. We have two forces. One is the difference in the velocity of the traveler, or the target. We use T in ethereal mechanics to mean the target. So the velocity of the target with respect to the ether, that's a difference in the speed of the ether and the target. And this is more of a viscosity force that holds the person toward the ground. And the other one is the inertial force, the acceleration, the relative acceleration between the target and the ether. Now, this is the model I had 20 years ago using inertia. And electromagnetic induction is how this couples a person and couples him to the ground. This has come much later, like almost 18 years later. Now, the reason why we're not going to consider this in the electrogravity part is because this is a very, very, very tiny effect, very tiny. We're going to consider this viscosity component for the large-scale ether models that we're going to discuss in the 5th paper of ethereal mechanics called cosmology. Because at large scale affects the scale of black holes.
Okay. Yeah, this one is basically saying this is the acceleration that's the difference between the ether and the object. This one is velocity. But anyways, I'm not exactly 100% sure what he means by that. Tammy says dust is dust, another method of increasing size. What do you mean by dust is dust? Is that cold fusion? And also, what do you mention? So does every action have an equal opposite reaction still in this instance? Yeah, that's still just still applies. Honestly, why not? This is just being sucked into it. And the question is, the other question is, why is the surface not being sucked in, or how is that being held in, or what mechanism is sucking it in relative to the surface as well? But the surface is also being compressed, so everything is being compressed. So the question is, what? Yeah, then internal. But I would assume that it's being crushed, and then eventually that's why you'll have a part right here where the magma, liquid magma, is if it's either super hot or not. Depending on it's cold fusion or regular fusion. But anyways, yeah, so basically it's being compressed into this spot there and going further. But then basically the idea is everything's sucking in ether. And yeah, the action, reaction stuff, yeah, that's just, that applies anyways. I don't see how it doesn't. This is just gravity being sucked in, ether being sucked in. But anyways, I want to show this part here. Here's a very interesting point right here. So he's saying everything is sucking in ether, and he had a decent argument for this. So if you have a drone right here.
The video. Okay, so take a drone that's hovering over the ground at about, let's say, 1 meter, just to keep the number simple. Right now, this drone is going to be spinning its propellers, burning fuel at a certain rate to maintain a nice constant height over the ground. Okay, now, if we burden this drone with a heavy cannonball, now the drone, in order to maintain that 1 meter height above the ground, has got to burn fuel at a much higher rate. Okay, it's going to be expending energy at a higher rate to maintain the kinetic energy of the cannonball. And what do I mean by kinetic energy?
Potential energy, man.
Well, now that this cannonball is in this state, 1 meter above the ground, its potential energy, rather, is going to be mass times gravity times height. So in order to maintain the potential energy of this cannonball, this drone has to burn fuel. So we're going to get into the concept of burning fuel to maintain a static state. Now, off to the right here, we're going to put a post. Let's say a wood post. Doesn't really matter that much what it's made of. Just sitting there all by itself, and then all of a sudden, we put a cannonball on top of that post too. Well, if this drone had to start burning fuel at a higher rate to maintain the stable height of this ball, then when we place the ball on top of this post, then that post must also be burning some kind of energy in order to maintain the stability under the same added stress, because this is under the same, this is reacting to the same load that this guy is, and there must be along with the conservation of energy, there's got to be some rule about the amount of fuel used for the same job must be the same in terms of not type of fuel, but in terms of joules per second of fuel being consumed. Okay, so, and now if you take the cannonball off, well, the top of the post is going to be held up by the bottom of the post, and therefore the bottom of the post must be burning some kind of fuel to maintain this extra weight at the top, because if you cut the post in half, then the bottom of the post isn't going to be under as much stress if the top of the post weren't there. And then you go all the way down to the lowest molecule, and you find that matter must consume some sort of fuel to maintain its state, its shape, its contained energy, yada, yada, yada. And so matter must feed to exist. And ether is the fuel of matter. Matter under stress must consume more fuel. Now, in the example I showed on the previous page, the addition of the cannonball to the post is not going to increase the ether consumption that much, because ether has an immense amount of fuel. So the total ether consumption will go up, but it may not be measurable because ether contains an immense amount of energy.
All right. Yeah, Rodin Mush says, isn't it that down to the structure? Would it post as paper, as to paper would crush it? Yeah, I know, but that's not the issue right here. The issue is you have a post, anything that's able to hold a cannonball. If you have a paper is too weak to hold it. It doesn't have enough mass. But what he's saying is that if you have something and you have put some stress on it, so for example, if you have this this eraser, this eraser by itself so basically everything's consuming ether as fuel to exist in a static state. But if I was to crush it, I'm just pushing it down. It's being crushed, but it's still holding its state. So then he's arguing that in order for it to still maintain this stress, it needs to absorb more ether. So, and then I think he has some other, but what I like about him is he's actually making a 3D model and then use it to calculate quantities. But he's in a bit of a slow pace. But anyways, it also needs to get on the Hudson effect and all that stuff. But I'm gonna go over right here. He has some good points right here.
And so, because massive objects consume the ether, and the ether is very fluidic, it must observe all the same properties as any other kind of fluid, including the spiral ascent down the sinkhole that's consuming it. And we can see this in the behavior of galaxies. Now, this is an animation. There's no way that humans have been around long enough to photograph this. It's not a perfect animation, but it gets the point across. Okay, but in order for a fluid to have this behavior, it must have density, it must have viscosity, it must have compressibility. Okay, and when we get to the cosmology paper, the 5th paper in the ethereal-mechanics series, we're going to demonstrate the galactic simulator, which is nothing more than a big wash tub, and it's going to be fitted out with motors and sensors to monitor the flow of the water in our simulated galaxy. And with this setup, we're going to show you that we're going to get the same anticipated curves. That this is what they expect to get from the stars in the galaxy from the distance from the core, and this is what they observe. In actuality, ethereal mechanics says you should be able to get any curve between these, and even curves that go up, way up like that. There's also a C curve. Okay, so based on what's going on, how old the galaxy is, and what the structure of the galaxy is, you can have any kind of curve from A all the way up to C. And we're going to demonstrate all those with my simple galactic simulator. We're also going to be using this simulator to show up properties of light. We're going to use it as a wave tank as well. It'll double as a wave tank. And I'm going to show you how a Crookes radiometer works using water as an analogy.
All right. Anyways, it's pretty interesting stuff here. But again, here at MES, I need to see some solid experiment stuff. So ether consumption is basis of gravitational field. So that's I do like that idea. I think there's some truth to that. And again, when I analyze stuff, I try to do it as a how do we get some sort of experiment to make sure it's all correct. So matter is comprised of 2 more protons, orbit massive amounts of ether is consumed, most of the radiation is contained. Anyways, so he's got his own model, but I do like Einol Dinu's paper right here. Einol Dinu. Okay, let's go to Einol Dinu. Okay, so we go right here. And I want to go over to his paper because he has some very good analogies of this is one I uploaded to my MES experiments where you had literally so if you haven't seen this one, so basically so I'm firmly on the side of ether, somehow include ether and then do experiments, and you'll get you'll get closer and closer to what no world reality is. So this one here I uploaded from I know the Unios one. So basically, if you have rotating, if you have just rotating discs in water or rotating cylinders in water, they attract if they're spinning in the opposite direction, and they repel if they're the same direction. Similar to the yeah. So here's repulsion. Yeah. So it's repelling even if you put them together. It repels. So, and I have and this one here is spinning opposite direction.
So let's see what happens. We start motors now.
Yeah, so they're attracting.
We see that the cylinders attract each other and now are sticking to each other.
And then same thing here. Interesting why it does that. Okay, this one here, if you have this rotating this way, a magnet this way, and then curl of the fingers. And also, I do want to brag slightly, because so if you compare my science stuff, it's like I'm trying to do it in a way that it's understandable to people, and also for myself. But if you look at Ashton Forbes and Jeremy Reese and all that, they throw around a bunch of jargon that is literally, what in the world are they talking about? Wormholes and all this stuff like that. And MH370 teleportation, wormholes through obvious cartoon fake videos and so on. Anyways. But nonetheless, they do touch some stuff that's real, but then they throw in their own disinfo. Anyways, so if you have this magnet right here, north, call it north just by right-hand rule. So right-hand rule, if you spin this way, north is the upside, south is the downside. This indicates the direction of the cylinder rotation, and the thumb corresponds to the north pole of a magnet. The light green side is north, and the yellow side is south. Opposite poles attract for both the cylinders and magnets. Yeah, so you have, these are opposites that they attract in water. Like poles repel, and the same behavior is observed for both the cylinders and magnets. Yeah, so here, if you put the like poles together and then let them go, they flip on the sides. Exactly like the magnet flips, and then they flip and they switch sides so that the opposites. Even when placed on their sides with like poles parallel to each other, both the cylinders and magnets repel and behave the exact same. Is a magnet just a vortex in a fluid-like substance called the ether? Yeah. Yeah, so basically, I think if we combine those topics, so basically, ether is just absorption. I mean, all matter is absorbing ether to exist, and when it's rotating at a coherent rate or fast and coherent rate, you have a magnet, and if it vibrates, you have pretty much radiation. And this one, I'll upload these ones later as well. This part right here. So here's a vibration of the ether, just literally vibrating. Like it's creating a balance between them to harmonize, sort of. Yeah, something like that. Because you can make anything magnet. If you have a magnet and put it on it, and eventually both of them become magnetic, just by rotating. Basically, it's rotating the ether around it, so you can get other things spinning it up if you can spin the ether. So if you have this is an example of radio waves. Radio waves is just back and forth electrons. So let's mute the thing. So he's literally just vibrating little tennis balls back and forth. You get radio waves. And so on. I mean, you get these water vibrations vibrating back and forth. And that's literally what radio waves are. So, and we can ask Brock right here. Actually, here. Radio waves from vibrating electrons. So that's just basically AC, alternating current, and then you have radio waves. So radio waves, yeah, high frequency oscillator. And, oh, this is a dipole. This radio waves are produced. Oh, this is to split them up. But anyways, you get these other stuff right there. That's interesting. That's another setup there. I didn't realize they use a splitter. But anyways, that's a splitter to vibrate it. What I want to do is this. Okay, so radio waves. So here's radio wave. There's an example of these are. I think this animation is showing. These are showing electric field. But anyways, the whole idea is you go up and down, and it vibrates across. And there's some circular. That's just electrical field. I don't know. But again, dealing with electrical field, I think. You could view the electrical field as kind of like the different gradients of the ether vibration. But if it's ether vibrating, if it goes, I think better with sound. Sound would be better. But anyways, I hate when they call electric field lines as opposed to. So this is kind of where I think the confusion all happens. Like the mainstream physics is adding these random circle stuff like that, as opposed to what's the actual fundamental thingy. What's the electrical field? As opposed to if it was just the ether, and these are just a calculation based upon ether to get this, but the actual one is just a sound vibration. I think that's what it is. But anyways, I want to go back to this Einaldino, because he and I put links to his papers. So Einaldino unraveling. I just want to go to the PDF. ResearchGate. Einald beyond mainstream. Okay, this one here. This one is in here. Okay, this one here. Anyways, rudiments of a theory of ether, and this was a paper he did. And his idea is just ether vibrating. And one images, some images that are very very telling is if you have the space footage when they're in the satellites in space. Assuming space is real and this isn't some sort of psyop. It behaves very similar to water, like when you're floating in water. So here's an astronaut, and here's water. It's like you're moving slowly, as if you're literally in a fluid. In other words, you're literally in the ether. And it's like the same behavior is observed in both, and so on. And I was gonna do a video on this, calculate it all out, and yeah. So going back here, basically the ether, the other part is permeates all material bodies and moves easily through the volume. So it goes through everything, and so on. And because when you have everything's mostly empty space, in other words, ether can go through it all. Liquid permeates material bodies, and you could even see everything's got a little. So it's going to be really, really small to go through all the crystal lattice of everything, even iron and so on. Seeing the two towers in the flow of the magnetic field is a key part of understanding. Yeah, that's interesting as well. Okay, so and the other part is he basically, if you can try to explain everything as ether, just a fluid with tiny particles of fluid, and then and from there you can actually possibly calculate everything out. So going back here, this is ether explains magnetism. This one is if you have ducks moving like this in a row. So here's a duck waves in the ether, and then if you have it like this, you have a bunch. You pretty much have a wave like that. It's as if the astronauts were in water. Yeah. So that's the thing. Well, they behave like water. So again, assuming the footage is real, it does look like it's just ether as a fluid. Ether wakes magnetic field, and then basically as electrons you go back and forth. You have direct current is all going one direction. Alternating current going back and forth. You get radio waves that go on and so on, and so on here. I'm going to keep going on. And some images that are again really good, really demonstrative of this is this part right here. So if you have current going this way and you have a coil this way right here, see what Faraday's what explains this one here. Consider, for example, two coils with the poles facing each other. So if the poles are facing each other, this one is out is this way, this one's out that way. They're going to actually be in repulsion. The charges flow in identical directions, therefore is an ether vortex whirling around the coil in the same direction. Oh no, the same direction. With the poles facing. Oh no, these are the poles facing each other in. No, this is in which direction? Okay, that's pushing it out that way. Look what happens in the space between the poles facing each other. The bottom of the vortex. If you apply Bernoulli's equation, anyways, I think he's talking about which one he's talking about. This one here. But again, if you have something like this set up where it's, current's going around this way, this one's current this way, because they're going in the same direction, they should be attracting. Actually, no, this one's going in the same direction right here. This one is rotating this way. That's the current. Why is it like that? Okay. Oh no. This is the current going in there. This one's out there, and this is the one that's together. Okay. This one here. If it's basically, if you look at a coil and then another coil, if the current's coming out in the same direction, they're gonna be attracting. If they go out opposite directions, they're gonna be repelling. So basically, what I'm trying to say is, you can literally just by looking at this, you'll know what happens to this. If you have a coil and you have a wire, if you just spin, if you have the current going this way and this one's going in this direction, they're gonna be attracting. If you have this current going the opposite direction, it's gonna be repulsion. And if you have alternating current back and forth, this should be just vibrating. This should be going back and forth. Yeah. So, anyways, definitely check out this paper, guys. If you haven't checked out this paper, this one's a very, very powerful paper. Helped me grasp a lot of this stuff he's talking about. And then he goes over the same cylinders that we went over. And I did so this is one of the same cylinders he discussed. And yeah, he allowed me. I asked him if I can upload the videos, and he said sure. And the other part about this, even mechanically, if you look at this one right here, I did way back. You can go to the experiments right here. Click experiments. Okay, guys. I want to go over this part right here quickly. Where's the experiments? This one right here. This one's a very simple one, and I just realized, hey, that's exactly what Inaldino was doing. So even mechanically, I think I semi-discovered this. I don't know if anyone else did this experiment. So if I spin this clockwise, watch what happens. So that's a heavy metal spinning top. This one's a lightweight plastic spinning top. So I do 5x just to see how long it lasts. Actually, no. Actually, I did it just so it lines up like this. So it's perfectly. It's not wobbling anymore. Now I spin this clockwise. So I spun both of these clockwise. So then, if this one's spinning clockwise, this one's spinning clockwise, they're gonna hit each other. So it's hitting each other right here. So they strike each other, and now this one's gonna die out soon. So they're fighting each other. So watch what happens here. I'll fast forward. And now this one's going to die out because it's weaker, it has less inertia, less drag on the ether. So now this dies. But if I spin it opposite direction, even though this one, it doesn't actually spin that long. This one's only spins like a couple minutes. This one can spin like 10 minutes long. So now I spin it in the opposite direction. So they strike with the same direction. So this one is actually going to speed this one up. This one's about to die, but every time it's about to die, it literally just it gets caught up by this. So plastic top gains speed from the metal top. And then 5x speed. Again, this is very simple, but just I think it just helps illustrate coherence and rotation. And again, it's about to die, and it just spins it up. It's 5x speed. And it lasts as long as this one. This is a fascinating video. Again, it's very simple, but very fascinating. And it's almost about to die, but this one keeps spinning it. And then both fall at the same time. So again, this one's... epic experiment. All right, again, going back, that's back to the ether. All right, I'm gonna close some stuff, and then this one, gravitational lensing. I think that's just light hitting the particles. That's just light interacting with the actual ether. And again, what light is just vibrations. Everything is just vibrations. These videos are how I found you. Epic stuff beyond illusions. Yeah. The MES experiments are epic. And speaking of gravity, I am working on one right now. It's MES experiments. I'm currently working on one. This one is gonna be with. So if you guys heard of the Boyd Bushman videos, or the claim, I'm trying to get in touch with John Hutchinson. Can you please let him know? I love to talk to him. All right. Yeah, for sure. Note that John is in hospital right now. As of this morning. So he may not be available for a while. Okay, anyways. So I'm currently working on an experiment. Well, it's not my experiment, but it's eventually I do want to do it. This one's going to be on the opposing. This one's from when I was doing my stream last time, and then yeah, I think last Wednesday stream, Paul Mueller joined the show. So I'm going to do Lenz's law, opposing magnets, and I have all these videos from here downloaded, and I'll show you them in a bit. So first of all, Boyd Bushman, opposing magnet experiment. So if you haven't seen this one, let's just see some images. Dr. Bas awkward. Neat. Yeah, that one was pretty epic. So if you go right here, Opposing magnet. Is this a opposing? Which falls faster? Non-magnet, magnet. Okay, this one was the one that's together. The claim was that if you drop magnets that are glued together at the poles, it should go faster. Okay, what does this guy have right here? Oh, he has this tube as well, magnetic copper tube. Is that where he got it from? I've never seen this video. We're doing.
Okay, I need your hand. This is a standard tube, and you're going to catch these. These are magnets.
I hate the music.
Okay, now do know
the music just takes all the copyright off.
that this is copper. It does not care about copper at all. It is not like iron. This one just
straight through,
plunks right on
less
through.
than a second.
And this one,
1,002, 1,003, 1,004, 1,004 seconds.
No, that's true. So now,
So you're canceling
now
out gravity.
well, buy something that cares little about
The
magnetism.
two opposing forces in here.
It's a matter of what is the aluminum doing. What does it care about?
Okay, that one is just the basic lens law, Mumbo Jumbo. The mainstream all knows, but Matthew's Solution. I have the Time Magazine special 9/11 edition from 2001. There's some interesting stuff, photos. Wondering if you've seen it. No, I have not seen it. You can send me the stuff, and yeah, I would have to look at that. I've not seen that. And again, if you can post stuff here, especially what I like best would be if you're on Telegram. If you're not, just get on Telegram. Just easier. So on the stream, so stuff that you find, or you could put, because you could put links right here in the stream. I mean, from the stream, you could put them in this Telegram. Otherwise, put them, or eventually put them all on here. It'd be pretty cool on the Threadcast. Threadcast would be next level. But if you put in and leave a comment right there, put all links there and so on, and we can open up in real time. And also we'll know what we dealt with in here. But also, I do want to put this stuff right here. I know Dinu. I want to go to the. I'm gonna put this right here. This one's pretty cool. So for example, basically leave a comment just so everything is in there, and also yeah, I'll just put that like that. Another part is some other stuff that we thought was pretty cool. This one's pretty cool. I'll put this in there, just so everything is in the one place in the discussion underneath that video link to the stream. And then I do want to put the Einol Dinu, no, not the other one, Ethereal Mechanics. Yeah, this one right here. The gravity one we watched just now. Electrogravity. Gravity. See the electrogravity that we watched. Gravity and matter. Electrogravity, matter, and ether. So I do want to put this one here, just so everything's there. So again, if you have something, you could also post some in this, and then I'll open up live. It would be easier just to go through it live, and also know where we got it from. Okay, so that's that. A century of stagnation exposed. Yeah, again, quantum. I think general relativity, quantum mechanics was to stifle gravity. Again, that's the big G in the Freemasonic stuff. Okay, so this is one here. Boyd Bushman. So he argues that if you have opposing magnets, they fall down slower in gravity than a regular magnet or regular particle mumbo jumbo. And then going back, where does it? Anybody? Why is nothing open? Like, just open the link. So Boyd Bushman, a recently passed Lockheed Martin scientist, spoke about an experiment where two forced opposition magnets react to Earth's own magnetic field, reducing the falling speed of bolted magnets. I tried this earlier, and now I want to test this without the few mistakes I made. So so apparently he did this experiment. So then this guy did it with these Boyd Bushman force poles. So he did it like this, and yeah. So and then he dropped it, and I think he was. Let's see how he drops it, and it goes down slower. But this one is very. The difference is very negligible, and you need to go really high height. But what this guy, so what Paul Mueller did, Inventor 3. So Inventor 3, what I'm working on is basically putting his videos into one video and cropping it all out. If you go to oldest, so again, this is like I've never seen anyone else do this online. There's one picture from the magazine that shows a building laying on its side at night with all the emergency response teams digging through rubble. It's really weird, interesting. Building laying on its side. Yeah, that'd be that's interesting. Anyways, if I scroll through here, and then go to anti-gravity effect, magnet through copper tube. So we all know the lenses law, Mumbo Jumbo, where if you drop something through a aluminum thing. But he has videos where if you put the opposing magnet, it literally it goes down twice as slow. in a copper tube. So here's.
I'm gonna drop this magnet in there.
So first of all, I'm gonna put all the videos in. Actually, I think what I'll do is I'll just open up. Yes. Anyways, you can go through here is magnetic copper tube. This is from 14 years ago, guys. So he's way ahead of the time. And I'm gonna go open up lens law opposing magnets. I cropped out some of the stuff here. Okay, so I'll just do that. I'm opening up the Camtasia file right now. And we'll see what I'm working on. This is the video I'm working on. Because again, this stuff needs to be like widespread. Like, he's the only one I've ever seen do this experiment. And I'm shocked nobody's done this because the Boyd Bushman claims with the going against gravity, that one, it looks like you need a really big tube. No, I mean you need a really like a high height, and the difference is very negligible. Unless you have super powerful magnets, and you need to do it. It's harder to do it. Oh, this guy here, this guy's commenting on my Dr. Reimer here. Stop making stuff up. Stop making stuff up. Hammer is Dr. Hammer. It's great. Anyways, this is against the and then yeah. Anyways, if you haven't seen the Dr. Hammer, the German medicine is absolutely amazing. I think that's the closest to real medical science. Okay, so and I have this video I'm working on. I'll just show you some of the stuff. So basically, he has a 6-foot long tube, and I think he starts dropping something here. Okay, what else do I have in here? And then I started a timer right here. Actually, go back into this one here. I'm gonna go unhide just quickly. Yeah, just so we have everything. So this one here, so 6-foot long tube. Here's the dimensions of it. It's 0.686 internal diameter, 0.75 external diameter, and then he drops it right soon. So here's a magnet.
I'm gonna drop this magnet in there.
This one's a small magnet right here, and then this one goes down.
It's got a very strange effect. It helixes, it wobbles back and forth.
Whoops. Okay, I'm gonna go. Okay, this one. Let's say this goes. This one goes down 11 seconds. Anyways, and then he has a bigger one right here. Actually, needs to be opened. Okay.
This one now.
Okay, now he has a big magnet. This one's a big magnet, and let's see how long it takes to go this one down.
Same diameter, 0.625.
Okay, let's see how long this goes down the copper tube.
Get over there. I hope to God you can see this, or it's turning out. I have a feeling my camera is not focused on it.
The star spinning as it's going down. I'm not sure if this one spins, but he has a ball that spins in there. But some of these wobble, and he has an interesting finding that the south, if south side is up, it's like tilted. It tilted at 2 points, but then the north side up, it just goes down straight.
Let's stick it right inside there. Alright.
Okay, and then the next part is right here. What he does now is, let's see what he does here.
Alright.
Oh, this is north side up, and again, it's gonna be similar to.
God, why does this always happen when
It looks like just going straight, but it's hard to see. I actually asked him to do the experiment. Yeah, so he's gonna be joining the show. Him with John Hutchinson. That was the plan on April 5th. I asked him to videotape this in HD, and also he still has the tube there, this copper tube. And also, in the April 5th, he may do a live demonstration of it. So that'll be, and we can ask him questions and then tell him to do different stuff and so on. See what happens. Anyways, so this goes down 20 seconds, around 20, 21 seconds, and then he's done it with a bunch of these. I just want to go through what else we had. I cropped some stuff out.
Let me show you with south side up again how it drags.
Okay, this was dragging. Anyways.
Okay, this is Paul, Inventor 3. Believe me, that's hanging square. It's my lab and the Tesla coils that are crooked.
He added, I think he added another like 5 feet or something to this.
See, in our last video, we did the experiment with the magnet through the copper tube, 6 feet long. Hopefully I get a better picture this time. Illustrating magnetic fields reacting with the copper, creating eddy currents.
Anyways, okay, now what he's done, he taken that same magnet and then now bolted it together on opposing poles. So it's double the weight. The other one was, yeah, 20 seconds, but this is a bit longer, so it should be 24. I think we'll see what he has.
I'm going to show you here. This is 2 magnets now. I have
Anyways, he shows the viewing film. It looks like it's 2 poles right there.
together. You could see that the pole or axial divisions of north and south are slightly off center. They're pushed off center. Oops.
Yes, that's how it looks off center. And then now here, I need to see exactly the dimensions he has here.
2 more copper tubes. So this is our original one up here that's 6 foot long, and I have taped on here. See how it gets larger in diameter. There's 2 additional tubes, so we have 3 tubes that are together. I'm going to show you this effect in 1 second here. I just want to give you all the info on it. Okay, we added a tube over our original first one. That was the dimensions that I gave you. The second tube is 0.775. OD is 0.875. We got it up to 30 seconds.
Okay, yeah. So basically, that same magnet, I'm not sure if you filmed that one, but that one goes 30 seconds now in this new longer tube. It's because he added 5 foot over the 6 foot. So that's going to be over the first one, so that's going to be 11 feet then, I would assume. Or 5 foot over, I'm not sure. Yeah, but it looks like 11 feet tall.
First original video, we had 20 seconds. Okay, I added a 3rd tube. Okay, now adding this, the second tubes, second and 3rd tube are only 5 foot long, as I just showed you a second ago. But these are the dimensions on the 3rd tube: 1 inch 025 ID, OD 1 inch 125. Now we got the magnet fall through 40 seconds. Okay.
Okay, so now this one is now added. This one, first 2 tubes. Again, I gotta just confirm exactly what he did with here. This is the first one. Okay, now I think this is the full length right here. This was now added 5 inch long over the first 2 tubes. Okay, this one is not 11 feet. This one's 11 feet. So he got 40 seconds for one of the tubes. I wonder what happened in a gold pipe. Interesting. Well, if you have a gold tube pipe like that, someone might steal it. And it's hanging in your tent, and it's worth $50,000. Someone's gonna take it and run away.
Now I'm gonna show you the south.
All right. So again, to drive home the point, the current one he has, it's about I'm assuming 11 feet. A magnet, just one of them. Again, this is now double the weight. So double the weight should go, would also contribute to going faster down. So a single magnet goes down 40 seconds. And then he's able to get it in 50.
South, 2 magnets super glued together, falling through the 3 tubes together. The one 6 foot tube, and then the other 2 tubes added on that are 5 foot long that go down there. So there's a good space in between my aluminum ladder and the copper tubes, so don't think they're affecting anything.
So I need to know the exact heights. It looks like it's about because I'm not sure if he put them end to end, so it's probably going to be around 8 to 10 feet around there, because he's on the ladder. So eddy currents is what slows it down. That's the mainstream reason. But what I'm trying to say is the magnets opposing goes down much slower, and nobody's done this before. Hi, Matt from Brazil. I'm late. Okay, and also even though despite the weights, yeah, high EQ or EQ. Anyways.
Okay. Here we go.
Hey guys, we have how many more minutes? We have 28 minutes left. Again, this is the power 2-hour power stream, just to force me to do technical mathematical stuff like this. And science stuff, as opposed to just conspiracy stuff. Anyways, let's play this.
Let me
good video here.
Let's leave it like that.
Okay. Here we go. 3, 2, 1, drop.
All right, so it goes much slower.
Come on, focus. There we go.
Look at that.
That's beautiful.
It's
hard for me to keep.
It's literally like frozen in air.
Camera perfectly centered here. I'm trying my best. Come on. Every time I get over it, it's what the heck is going on? Get down there.
It's still going.
Still falling. Let me show you. Okay, still falling. Down there. Whoa. Okay, you could have to watch on the videotape how long this is actually taking here. And it should be. Whoop, just fell. Just heard it. I hope you heard it. It's rolling over there on the floor.
Okay, I'll be putting a timer on this and so on.
50 seconds.
Okay, this one he's saying 50 seconds, but he got it to over a minute. And another one. Hi Matt, have you ever done a live talking about the man on the moon? No, I haven't done that. That'll be an interesting one here. I do want to get. I semi want to get Bart Sabrell, but I think Bart Sabrell's might be a Richard Gage type. But I could do one, yeah. I could do one eventually. Maybe even this week's stream if we want, because actually not this week's, next week's. This week, special guest Daniel, Dr. Nagas. So next week, my solo ones, yeah, I might do a moon one then. I've never done one. I could do a moon one, looking through Andrew Johnson, Richard Hall's work, and Bart Sabrell's, but also on the debunking side, because some of the stuff, not the moon landing is again, you have to always put 9/11 in mind. 9/11 has like 700 different layers. So the question is, which part of that, which part of the layer is like the true one of the moon landing? Is it all fake? Is space fake there? Was there some real elements to it? Did they actually go there with advanced tech and then just use the fake cutouts for us to laugh at? And so on. Similar to 9/11. 9/11 involved direct energy weapons, and then but all the people know is explosives or jet fuel. There's no middle ground for those peeps. So it's again, and that's the thing I was diving into. Anyways, that'll be an interesting one. Maybe next week. Okay, so now he does it again. I just want to see. He drops it again about 50 seconds. I think this one gets stuck. Okay, anyways, going back here, he has a timer on this one.
Drop our 5/8 by 1/2 inch long neodymium magnet in.
Okay, so but he doesn't. The one he did, the actual control one should be the ones in like just opposing ones together, and then seeing it because they have the same weight. He does that. He says it's 24 seconds. We'll get them, or 28 seconds. Anyways, we'll keep going.
Let's see. 3, 2, 1, drop. Okay. You see, I got some magnetic viewing paper on here also. Let's see here. This is the halfway point.
Yeah, just want to keep going.
Where is that sucker?
Oh no, someone's already go down, I think.
Whoops, must have missed it. 'Cause here it comes. Down here. Let me do that one more time.
Okay, anyways, what I'll do is I'll pretty much put the timers on and then make it so that it's digestible. Okay, so he graphs out the different parts. Anyways, I just want to get. I'm gonna skip a lot of this stuff, but I do want to get the final numbers he gets. Okay, where's the numbers he puts in? Okay, I'm gonna go to the numbers that he puts in. Okay, and he also discusses some interesting anomalies in the magnetic field. But I do want to power through this one here just so you guys have a preview. And also he says that the north side has a stronger magnetic field for some reason. And also if you have this is an interesting one I might include as well. There's some when you put the opposing ones together, there's not an equal on both sides. What ends up happening is this side has like a 0 point in the center and north and a south, and this one's all south. So something's really weird. This is when you have north and north together. This is how the magnetic field looks like when you have north from the sides. So you have a 0 point, and he also, I think he does he measures it out, I think. Anyways, I just want to power through this. Okay, and also it tests out how it looks like on the cathode array TV.
Together. This is one magnet with opposites attracting, or two magnets.
Okay, this is just a regular magnet, regular two magnets stuck together in attraction.
I mean, with opposites attracting. Let me show you this on our CRT screen here. These.
I'm gonna take a screenshot. This is pretty interesting. So it looks like this. Okay, that's how this one looks like, and then see how the other one looks like.
Are two magnets. Okay. Take a good look at that. Strange. I see.
Okay, I'm gonna take a better screenshot, and what I'll do is I'll actually post this on the Telegram. Okay, so we have this one. That's this is the attraction.
Big black bar going across the screen, and believe it or not, this shadow bar is only in the camera. I do not see this with my visual.
Oh, he's saying that this shadow is only in the camera, not in the actual visual. So that's interesting.
Right now. Very interesting. I don't know where that black bar is going across. I wonder if it'll come out on screen. Anyhow, okay, look at how the fields are spread apart. Now, let me show you. These magnets here are with opposites. I'm sorry, same poles together.
Yeah, these are the ones super glued together.
And you can see it's much more condensed. The field is much more condensed and sticking out the sides more.
Yeah, see how tiny it is. Okay, that's pretty fascinating. Okay, so what I'll do is I'll put these ones in, and I'll put it in the Telegram. Okay, we have 22 minutes. So I'll put this right here. And it's in attraction vs super glued and repulsion. And then then we can see the difference right here, and so on. Actually, whoops, this is supposed to be in here. Okay, this should be there. Yeah, okay, there it is. Yeah, so you get this is before and after, before, and after. So this is yeah, look how tiny it is. It's all condensed inside that area. This one is spread out. This one's condensed. So that's interesting. Maybe and similar matter is pretty much you have protons and electrons. Yeah, but then again, what's being I was thinking the opposite. But anyways, but you have protons stuck together, and they're like opposite of charges. So the question is, why do you have protons all stuck together? And this one is like you have a pole and pole stuck together. It forced together with a strong nuclear force, and there's a small condensed there. So we might be looking at what matter is, just opposite poles stuck together. And then when it's opposite, it's like that. All right, so that's interesting. Okay, now the next part is I want to get to the 1 hour long one. This might be it.
We're gonna time this magnet, two of these magnets with opposites attracting.
Okay, it says that's interesting because the compass surely seems to favor north. Yeah, that's interesting.
So.
Yeah. If you can get a good video on that, let me know, and then I'll put it on my MES experiments playlist.
Hang on 1 second while I set the camera down and start this clock here. Wouldn't be one of Paul's videos without setting this down.
Okay, he puts the camera down and then he times it.
Drop this. 3, 2, 1, drop.
Okay, so he drops it in.
Timer. Okay, let me let you guys see this.
So he started the timer after he dropped it, so probably another second after. Anyways.
What the heck is it?
And he has like viewing film all around it, so you can see it, but it's hard to see.
It's hard.
I told him to film a more professional quality one for my videos.
Get this on film. I could see it with my eyes. Got magnetic viewing paper. Here comes the magnet down. At this
Okay, there it
end.
is.
Let's see. 28.
If you film LED lights, you get those weird bars that are only visible in the camera. Interesting.
30.53 seconds.
Okay, no, this one's an attraction. Okay, that's an attraction. So this one's really important. So 30 seconds is this one here. This one is there in attraction, not in repulsion.
That's with two magnets, opposites attract.
30 plus maybe another second. So that's another, yeah, so about 30.
Now, let me show you real quick the other two magnets.
And the reason this one here, so this is 30 seconds, but if you have just one magnet, it's 40 seconds. So this one's actually fell down faster, even though it's a bigger magnetic field. The reason is because the weight is doubled. So now the weight is forcing it down. So it's less, the copper tube is less able to drag it up. So now it's, so basically 30 seconds or 31, 32, depending on when he actually started it. And then, yeah, and that's with the magnets in attraction. Now he does it again. Okay, now it's in repulsion.
With same poles glued together. Same poles glued together. Norths. And, oh, I gotta set this down so I can start my timer. 1 second. And we're getting ready to drop it. 3, 2, 1, drop. Okay. Drop our video here. Alright, where is it? It's right.
Oh, you can actually see it. Can you see that? You can actually see it going down through the viewing film right here, 1 and 2. Watch it slowly. Holy.
And now you can see that. It's falling through. Getting down there. Where are we at? 39, 40. Let's see if I can get a view here.
It's still going.
Clear. She comes.
All right, 1 hour and 3.64 seconds. Okay, guys, this is literally fascinating. So it drops double. I mean 2 times, or it takes 2 times slower than the equivalent 2 magnets in opposition. I mean in attraction. So 2 magnets in attraction fall down twice as fast as if you have opposite poles like glued together. And this is about 23 seconds slower than one magnet going down normally. Because one magnet, again, it has half the weight. Now this is double the weight of that other one. Yet it still takes longer to go down. Versus that if you have 2 magnets in attraction, the 2 heavy ones, they went down faster than one magnet because of the weight. And someone did a video, there's like a drop-off once the weight becomes too overpowering. But anyways, this is showing literally the same one, the same magnet. If it's in repulsion, literally double this. Half the speed. Is north, north, south, south, same speed going up. He hasn't. North. Oh, north, north. Oh, he hasn't. I haven't seen one. I think he's only done north, north together. I haven't seen him do south, south together. That'd be interesting to compare. And that's one thing I told him. So he'll be joining a live stream. That's something we could tell him. Literally in the stream, tell him. Can you do it right now? Opposites, south, south together, and north, north, and compare it, and so on. So it would be an epic stream.
1 minute, 3 seconds.
All right, so 1 minute and 3 seconds, guys. And then he writes down. Okay, now here's another wafer, carbon wafer floating on this. So this guy's got experiments everywhere. His goal was to replicate Hutchinson effect, but then he thought to himself, John had too many equipment to do it unless there's a simple way. And there's another one I might include as well. If you drop this right here. So these are in, I think these are in repulsion as well.
Long, 1/4 inch thick. There's actually 2 of them laying side by side. There's aluminum plate down there. So let me show you this. Square magnet. Okay, we're gonna put it.
Oh no, this is just a normal magnet. Okay, so if you have a square magnet, that's the center of it, or the node, or whatever you want to call it, or the block wall, or the inertial plane. Anyways, so you have the center. There's a south here, north on the other side. If you drop it like this, it's pretty interesting.
Or south facing out.
So if you put it like that, it rolls that way.
See how it rolls down. It's north.
So north and south always roll.
Rolls down. Very interesting effect. You could really feel it if you try to pull the magnet. You can see how the magnet wants to spin in my hand here. There's this resistance.
Okay, but now if you put it, if you put the center of the south and north on the going horizontally, this goes down flat. Yeah, this is a copper plate, and it floats out. So it doesn't roll. So if you have a magnet aimed horizontally, it slides down. If you have it vertically, it rolls down.
Magnet this way, and it slides.
So that's fascinating. Okay, so that's that, and then he goes through the papers, and also he goes through another part here. So this was pretty cool. This one is a magnet that has different poles. So it's like it's split up into north. These ones are like split up in north south all around.
Many sections.
And then what he does is basically takes a heavy magnetic ball. So that's how the magnetic field is. And if you just rub this on it, so he just rubs this on it.
Down again. So let me set this camera down here. Hang on one second. There we go. Let's see if we can see this. Here's our magnet. Okay. And here's our ball magnet. Okay. I'm gonna stick that on there. And I'm gonna move it around the diameter.
Yeah, so basically he's just wiping this magnet on this bigger one, and then what happens is this loses all of its different magnetic fields. It just becomes one magnet.
Okay. North side of the big sphere facing the magnet. Okay. Now let's set that big magnet down. Now I'm going to show you with this viewing paper. There's no longer any divisions.
Okay. So basically got rid of all the magnetic divisions in there. It's made it all one pole. One big magnet as opposed to many small ones. And there's the original one like that. That was pretty cool. I just wanted to show that. And anyways, I'm just going to keep going through. There's the Jacob's ladder.
This already. Anyhow.
All right. So again, fascinating. I want to get to the... Okay, and then they included... Oh, I forgot to get to the paper. Okay, so... the results that he included. Okay. So there's John and Nancy when they visited him.
Welcome to the lab.
Thank you. Wow, I'm honored to be here.
Will it come back or is depleted? No, I'm saying it's still magnetic, but he made it one magnet. Before it was split into multiple magnetic fields. Excellent find out. These are where chemistry is founded in, but disguised in mumbo jumbo explanations and explanation of nature. This few understand or enjoy. Yeah, I highly. Okay, I definitely view reality as much easier. And also, this one's okay, we'll play this. This was very interesting by John Hudson. Before we get to that, Nancy said something funny when she first met John. We'll get to that in a bit. I want to get to the results that he wrote down. He wrote down the results just to compare the stuff here. I don't know where the results were. I think I put it in my notes somewhere. Okay, let's see what the results were. I'm just gonna keep going. Okay, it should be somewhere, maybe in this paper, on this paper. Okay, I thought I wrote it down somewhere. Okay. Actually, it should be in this one here. Okay, yeah, this paper right here. Okay, it's 50 seconds, twice as much weight. 50 seconds, and then he got it over a minute, though. Okay, 28 seconds. Okay, I think he wrote it here, but then he did... This is the one with the other one, but he did it over a minute. So I don't know how he got it longer. Okay, I'm going to go back here.
Many combinations of different.
Okay, so magnet right here, 0.625 diameter. This one through the tube goes 40 seconds to fall through. Just a normal magnets, same size, glued north to north together. Fall, yeah, so there's double the weight, and then they fall in 20, no, where's the weight? Where did he put in there? Oh, 50 seconds. So it takes 50 seconds to fall through. Experimentally again, Siri is now working for me. Nor can you read my mind. Oh, great stuff. I'm loving your work. Okay, epic. And then also this just stopped working for some reason. All right, there it is. Make it live. Okay. Yeah, these are pretty epic stuff. Anyways, so this one in here, I measure with opposites together. So opposites together is 28.7 seconds. And then, but at the other case, so he did 30 seconds, and then he did 1 minute. So I don't know what the difference was.
That was the one that I just showed you on the video. Two of these magnets, same size, glued with same poles together, takes 50 seconds to fall through the tube. Now this is quite interesting because there's 2 times as much weight. And yet, if you take those same 2 magnets with opposites together, it takes 28.7 seconds. I've tried many combinations.
All right, so that's pretty fascinating. And then this part here, I just downloaded everything, put it in together. But anyways, I might not include this part, but in the final video. But I just want to play this here. Just really funny. Nancy talking about when she met John.
Yeah, and here we are filming each other.
It's camera day here.
Camera day, get the machine, Sunday.
Not welcome without a camera.
So John Hutchison is a machine tooling freak. I mean, he thinks that is his total ultimate. He's in heaven right now. Yes. Around all this stuff.
Absolutely.
And many people have commented on John's precision in his machine.
Yeah.
Yeah. John is absolutely precise when some of the cannons that he made, the cannon and stuff. I'm like, holy! I thought he bought it, but some of them he actually made. It looks professionally made. I'm gonna play this right here.
I could tell too. You see all the cutters and everything.
And what also John does is anything he gets, he removes everything that's plastic and replaces it with brass or metal. So for example, all the knobs on this lathe that he got, he removed every single one of the plastic knobs and replaced it with like brass spherical knobs that he machined himself.
So one of the pictures that he sent to me was he had something that he was grinding or whatever. There's this piece of metal with sparks flying off all over it.
Oh yeah.
And he was naked. So it was just,
anyways, listen to what he just said right here. Okay, so she said that he sent him a photo when he was grinding or some stuff on the ground and there's sparks flying and he was naked. Let's see.
all over it.
Oh yeah.
And he was naked.
Let's go listen to it again.
Precision in his machine.
Yeah. I could tell too. You see all the cutters and everything here too.
Make this a bit louder.
Pictures that he sent to me was
So one of the pictures he sent.
He had something that he was grinding or whatever. There's this piece of metal with sparks flying off all over it.
Oh yeah.
And he was naked. So it was just the stuff was covering up his privates, but you can tell he was naked. Like, that is really seriously wrong. You know, those hot sparks could hit something
that's art, right, John?
Want to be hit. You know, he at least put like a.
Sounds like a picture for a calendar there.
You know, yeah, really did. But I at least put something up there, you know, that's like a shield or something. So
yeah, right.
Get a hot spark on it, it doesn't burn it.
Yeah.
Woohoo!
I know.
I'm pretty lucky.
Yeah, faster. And then also we have 4 minutes left. And then he demonstrates that the exact same experiment. And also John gave him some samples. I gave him there. And then there's Paul Mueller's dad, John meets. And then I do want to get to this part. I think it was in here. Oh, this was him talking about his other stuff. Anyways, here's the experiment he does for John Hutchison. So that's quite fascinating. This one's, well, I think, yeah, this one is one of the only experiments ever. I've never seen anyone else do it in the world. I Googled it, I YouTube, nothing had opposing magnets going through this right here. And because this goes double the time it takes when you have opposing magnets. So that's fascinating. And this is, I think, This is the biggest argument for Boyd Bushman's claim that it goes down slower in gravity. So, and the fact that this is the only one I've seen online anywhere, and now he's showing John Hutchison, the John Hutchison, demonstrated to him live in 2011. This is like 14 years ago. It's like, why? And then somehow I get a hold of it, so it's pretty epic. So again, when I get hold of top level info, I put it everywhere, similar I did it with the John Hutchison's Hutchison effect. Because like right now, my playlist is literally the one to go to, and also with 9/11, I put make it anywhere and everywhere. So it's like you want to learn it, you go to my channel, and so on. Anyways, play this.
Drop.
And you can see it going down.
You gotta love it. It's brilliant. You can actually see it slowly make its way down this tube.
Isn't that cool?
Yes.
And then, let's see, I even put a mirror down on the ground.
Okay.
It's awfully dirty.
Well, folks, this is really amazing stuff here. Let me see
actually view if I have that at the right angle, and not if you could see up into there. Finally, how long has that been so far?
That's been quite a while.
I think I had it
Oh,
just over 1 minute so far.
yeah. So you said it got over 1 minute. The one we just showed you.
Who was it? Boyd Bush did the experiment with gluing the magnets, same poles together.
Yep.
And then I got an additional 10 seconds out of it too when I dropped it through there from doing that.
And again, he's saying additional 10 seconds. That's relative to one magnet. He actually made it an additional 30 seconds relative to the equivalent weight, because this one's double the weight. And I do want to check. Okay, we have 8 minutes left. I'm going to go quickly search. Again, watch his channel, guys. Definitely check out his... I'm going to click on this right here and his entire channel. Put this right here in the comments. Definitely watch his stuff, guys. Watch all of them. That's part 1, and then go from there, part 2, part 3, etc. Go watch anything with Hutchison as well. And what I also did was I included his interactions with John Hutchison in here. So if you go to a Hutchison Effect playlist, and I put his there, I put this one here, John Nancy Visit Inventor 3's channel. John Nancy Visit Inventor 3's channel, and also right here is the 7-minute one. And also I put his is John Hutchison real or fake? Yeah, the truth is obviously he's real. And I put that in as well. So at the bottom, so those were anything that makes the cut. I put them in this thingy right here. And actually, now I do want to show this part here quickly. Again, we have 1 minute left. As we're just trying to show anything. Hutchison effect. Hutchison effect. Let's see. There was one pretty funny stuff right here. So about John Hutchison. So John Hutchison sent Nancy in a naked photo while he was like. It's covered up with like random sparks being flying everywhere, and it was pretty dangerous. And there was something funny here. I was trying to find where it was. Where did I put it? Okay, there was something funny. Okay, Hutchison. Rare. Oh, this one here. Okay, guys. Rare Hutchison effect dustified all of Hutchison's clothing. Okay, Icky, thanks, man. Yeah, so here's John, the CBS Radio Los Angeles Hutchison Effect TV show. This one 5 years ago. What are you doing, John? And then Conspiracy Realist, I sent it. He said this is a Hutchison Effect, like 9/11. Notice how all his clothes were dustified, but not his hat. So it's selective dustification. So again, what are you doing? He's doing some sort of next level stuff there. Anyways. That's I'm gonna put this right here. Copy post link. So John Hutchison, absolutely wild. All right, let's go, John. It's the original Hutchison effect. Again, that's the hero of the world right here. That's the hero of humanity, saving us from with advanced tech. Anyways, that's pretty wild. There, that's that's the hero we deserve. That's the hero we deserve, guys. All right, guys. So that's it from there. And I think there's some other stuff. But anyways, I'll be working on getting this guy's work, put it in properly. So Paul Wheeler's amazing stuff there. I just want to check if there's any updates from my email about John Hutchison's health. Again, for those who came in late and so on, John Hutchison, guys. Okay. Carl Sagan's first wife. Plus 9/11. Okay, this one, famous scientist in her own right, purported to have died in 2011. And 9/11. 2001. Okay. She began looking into the evidence against the official account of 9/11. Interesting. This is Carl Sagan's first wife. Or, holy, okay, so she's a conspiracy a semi-realist. And she says 2, 3 down, the biggest lies. She wrote an article, WCC 7. Okay, interesting. So they're all part of some sort. And then David Ray Griffin. Ah, my goodness. Okay, so it's like it's all one giant Freemasonic club. All right, Larry commented here. I just want to check quickly what we have in store. And also, I wanted to go through one more thingy here. What was I going through? Okay, thanks, Mathman. Okay. Yeah, I wanted to check on, so John Nancy. Again, for those who haven't heard, same as last, his wife just sent it to me at literally 1 a.m. in the morning. So same as last June, had to give John CPR, so he had another heart attack for second time in a year. He's in hospital there in Willits. They're transferring him to another hospital, Santa Rosa. Charles is staying at the hospital with John, and will drive to Santa Rosa 1.5 hours away while they take John in an ambulance. They don't know when, so I'm hoping to get a few hours of sleep. So again, guys, prayers up for John Hutchison. Hopefully he's good to go. Okay, Tammy says, back in the day, yeah, that's a great one. Dosification of clothing, which I believe is based off the chemical makeup of each item. Yeah, and his hair, I mean, his hat is fine, though. And back in the day, I would have disliked him because of his crazy cross-dressing lifestyle, which is what I really enjoy about him. Now he's in his own, and it's all right. Me, it's like, I look at concrete stuff. You have something concrete, okay, we're going with it. I don't like judging people based on anything but what they produce and go from there. But again, take it. But again, he's a real deal. That's obvious. And everyone's got their own personality. And yeah, it's pretty funny, but but still, nonetheless, let people be their own people. But my thing is produce results, guys. Anyways, guys, great stream. Thanks very much. Yeah, we're gonna head out. Anyways, guys, prayers up for John Hutchison, and hopefully he is good to go. And anything else, and that's all. I'm gonna type it in right now. All right, guys, that's 2 hours. That's all for today. Thanks for joining, and prayers up for John. Up for John. All right, guys. Prayers up for John. Paste this right here. And yeah, on Math Q&A, guys, thanks for joining, and on the Rumble and so on. Okay, and okay, that's all. That's all for today, guys. Thanks for joining, and stay tuned for another Matthew Solution and ending the stream in 3,